Continuity test fixtures are crucial to EFI Connection's engine wire harness manufacturing. In this video, I will take you through my design process to make a continuity test fixture for an Aptiv Splice Saver connector. Using Fusion 360, I'm going to pull in some existing models to make this test fixture. First model I'm going to bring in is my aluminum base. Then I'm going to bring the pigtail in that represents the connector that's going to be tested. I'm going to position the connector on that movable lever so that it's held firmly in place once it's inserted into the final test fixture. I can take away a few components here that I won't need to see during the rest of the design process. I previously modeled a spring test pin that is already positioned in its test location, so I can now move this test pin in front of a terminal. I'm going to make a brief adjustment here to pull it back just a little bit. Okay, now once I've done this, I'm in a good place to pattern this test pin. Not quite ready to do that yet. I need to actually make the Delrin or plastic block that we're going to be machining. So here I am just creating a sketch, and I'm going to define what the height and width of that material is going to be. It's going to be 1.5 inches high, and it looks like we're going to make that 2 inches wide. I'm going to create that as a rectangle sketch. Now I can extrude that more or less to the front of the connector or the back of the connector, but I'm going to make a little adjustment there to give me some clearance. There we go. So that looks good. I'm left with a solid block, and inside of that block I'm going to change the transparency, and you're going to see that there is a test pin inside there shortly. There you go. So there are 12 terminals, which means there's going to be 12 pins. I need to create 12 holes. So to do that, I'm going to create one hole to begin with. I need to figure out what that hole diameter is. So I'm going to look at an existing fixture that I've made and pick up this hole size, 94 thousandths. I'm going to create a sketch, and I'm choosing something, a concentric feature, and then I'm going to draw that 94 thousandths hole. Here I am extruding that, bringing my fixture back in, and it recognizes that this is going to be a hole. And then very simply I can just pattern that hole 6 across, 198 thousandths is the center line spacing, and then there's going to be 2 rows. Okay, so now we have a block with with holes in it. So now I'm going back to that existing model that I've done, and I'm figuring out what that pocket is going to be on the back side so that I have clearance for the wires that are going to be soldered to the ends of those test pin sockets. So I'm going to create a rectangle, giving myself about 100 thousandths clearance away from the pins. Now I have to cut this feature, and I can't cut a rectangular feature with a round end mill. So once I create this pocket, I need to radius those corners. I'm going to use a 3/8 end mill when I machine that pocket, and that radius that I created is going to be an appropriate size to cut with the end mill. I'm going to pattern the rest of these test pins just to show them. It's not really necessary at this point, but it makes it look a little cleaner and easy for demonstration purposes. So I'm done with the back side. Now I'm going to move to the front side, and we have the test pins in location, and we're going to bring the connector back into the model. So we have to cut out the shape of this connector So to do that, I'm going to project to the sketch the outline of the connector. I'm fumbling with that just a little bit because I'm realizing that I have to make a couple additional considerations, and there we go. So we're going to have to rework those corners a bit, and there we go. We're going to add a couple points. All right, now we're just going to connect a few dots here, extend some of those lines, and then we're going to extrude that as a pocket. Again, I can't cut 90-degree corners, so once I do this, I'm going to have to radius those 4 corners, and I will probably be cutting this with an 1/8 inch end mill because they're tight corners. Oh, I've got good clearance there. Move to the next corner. We'll use the same radius, 70 thousandths. Got clearance there, we got clearance there. Okay, we're getting close, but there's still a couple features that we need to rework because we can't cut with even with the 1/8 inch end mill, we can't quite cut this feature. So I'm going to cut those angles out. I'm going to extrude or push those walls a little bit, and then I'm just going to radius those. Here you go. Just kind of drag that there. That's good enough. Do the same thing here. Okay, I'm happy with that. So the next problem is that connector needs to seat further than I've pocketed that material. So I need to consider that, and I'm going to have to create some sort of a recess around the edges of the connector. And I have to leave myself enough room. Here we go. I'm going to measure for my 1/8 inch end mill. So I have at least 125 thousandths, which is plenty, which is the clearance that I need around there. So I believe that number was like 130, 140. So I do have clearance to run my 1/8 inch end mill through there. To extrude that, and we're going to extrude it to the end of the connector, but we're going to add 10 thousandths for just a little bit of clearance. I will turn on the section analysis so that you can see that there is some clearance there. There you go. Notice there's plenty of clearance in there, and it looks good. The connector is going to seat all the way. Okay, we're getting pretty close here. Adding 10 thousandths to the top of my block because I'm going to laser engrave the part number and a logo, and then I will fill that in with an acrylic paint. And when I do that, I want to, when the paint dries, I want to be able to take it back into the machine, the CNC mill, and I want to mill 10 thousandths off the top for a nice clean finish. So here I am pulling the part number from a previous model, changing that from a 9 to a 14. I'm just going to reposition this because the material I'm working with here is a little bit wider than the material I was working with on the previous model. Going to extrude these. I usually just extrude these about 10 thousandths. That creates my artwork on the top. Now I'm going to create a sketch on the top, and I'm going to select all of these components again. What this does is gives me a nice sketch to work with that I can export as a DXF file. In another video, I'll show you how I import that into my laser software, and I'll use that DXF to create the artwork. That's about it for this video. In my next video, I'll demonstrate the CAM programming and actual machining of this fixture on our Haas mini mill. Thanks for watching.